I really like this as a teaching method, a learning method for getting better at equations. I'll read this question out. Are there 0, n, or an infinite number of solutions? Have a think in your own time, or maybe just watch me do the first one so you know what on earth I'm talking about. By the way, I've not prepared answers for this, and I think this is quite awkward, so I'm going to probably stumble a couple of times, but I think actually watching someone who is kind of good at maths, because I've had lots of practice, making mistakes can be quite a good way of learning as well. Anyway, um, hmm. Well, I could rearrange this to be x equals 9 minus y. And then I'm just going to combine these two. So that'll be 9 minus y plus 2y equals 9. Which means that y equals 0. I'm a bit nervous. What's going to happen to the x here? So, oh no, that's alright. And x equals 0. X equals 9. That's fine. So there are n solutions. In fact, there's one pair of solutions. Right, let's try the next one. Maybe, if you didn't the first one, maybe try pausing this one, have a go. Are there 0, n, or an infinite number of solutions? Right, x equals minus y. I'm going to combine these two. I love using arrows like this. I do this, I used to do this in exams all the time, and I think it's fine. So that'd be minus y plus 2y equals 0, which means that y equals 0, which means that x equals 0. Okay, that worked as well. So there's n solutions, as in fact, n equals 1, there's one solution. Let's try another one. The problem here is I could substitute. Oh wait, hang on, look. I know that xy equals 0. So I then know that 2 times, so if I combine these two, that tells me that 2 times 0 is 0. Well, ha ha, that's not telling us anything new. I'm going to try, do you know what? Maybe there's another way of doing this, but I'm just going to logic it out. X could be 0, in which case, so let's write this down. X equals 0 and y equals anything, because y could be anything at that point. Or y equals 0 and x equals anything. So I'm going to call that an infinite number of solutions. But we're dealing with infinity, which is a bit awkward, but let's call it infinite. Okay, what about the next question? I seem to be asking exactly the same question again. Okay, well, let's skip that. Let's do the next one. X minus y. So I'm just going to rearrange this to make x equals y plus 9. And then I'm going to sub that in. So I get y plus 9 plus y equals 9. So that means that 2y equals 0. So y equals 0. Again, I just want to, we still don't know, so we need to find out what happens to the x in this place. So that means that, oh, x equals 9. That works. So there's one solution. Fascinating fact, if you try and design your own questions like this, you often end up with one solution where one of them equals 0. That's why that happens quite a bit. But it's a way that we can cover lots of different types of situation. Am I going mad, or have I just asked the same question again? No, I haven't. Did I mess up last time? I bet you that when I did that before, I meant to make one of those a 9. Anyway, whatever. Have a go at this one. X, obviously you might have paused the video to have a go in your own time. So that means x equals y. So that means that y plus y equals 0. So I'm going to write it underneath. So y equals 0. Which means that x equals 0. Again, this is one of these funny situations where it's this is almost like there isn't a solution. Because if this was a physics problem, if I'm drawing on my experience of working as a mathematician or physicist, if you come up with two solutions that are zero, that's kind of like you haven't found a solution. It's like, well, that's useless. I can't use that. But from a strictly theoretical point of view, yes, that's one solution. So just to be clear, there are n solutions. There is one solution. Let's look at the next question. Sorry, I'm kind of jumping around all over the place here. Right, so here's your next question. Are there 0, n, or an infinite number of solutions? Right, what I'm going to do is this. I'm going to change that to x, y times y equals 9. So I've just spotted a way of subbing something in. And then I'm going to say that's x, y. Oh, do you know what? I'm going to cheat because I'm lazy. I'm going to do that. I'm going to stick a 2 there. So times both sides by 2. So then I can just immediately sub in my 2xy. So I can then just say 9y equals 18. So that means the y equals 2. So we still don't know. We need to find out whether there's a valid solution for x at this point. So that would be, let's do some working down here. I'm going to write x question mark, just so I can see what the working was if I went back later. So that'd be x times 4 equals 9. X equals 9 over 4. But I just want to double check it also works in the second equation, so I'm a bit nervous in case I made a mistake. So that'd be 2x, yeah, it's the same. Okay. So again, there's one solution. Now, there's a squared in there, so I wonder if there's a plus or a minus. No, I don't think so. If there is, stick it in the comments. Maybe I messed up. I'm a bit nervous now. Let's try the next one. Are there 0, n, or an infinite number of solutions? I'm going to rearrange that to say 2xy times y equals 0, which means I can then sub these in, which means that 0 times y equals 0. Well, guess what? Y could be anything, and whatever y is, x has to be 0. But is it also possible to say, oh yeah, you could also say x could be anything. If y equals 0. So we've definitely got an infinite number of solutions. It's this problem that if you've got two things multiplied, well, it's not a problem, but if you've got two things multiplied together to make 0, only one or the other has to be 0 and the other one can be anything. So that's what's happened there. Let's look at the next one. I'm going to rearrange that to be, I'm going to rearrange it here because it'd be easier. Let's make that x equals 9 over y. And then we sub it in like this. So we get 9 over y squared plus y squared equals 9, which means 81 plus y to the 4 equals 9y squared, which means y to the 4 minus 9y squared plus 81 equals 0. I wonder if this will factorise. I'm writing this out as I think. It doesn't make sense to me that it would. It needs to add up to 81 and have a difference of 9. Oh, do you know what? Let's just do x equals minus b plus or minus the square root b squared minus 4ac divided by 2a. So all we care about is the b squared minus 4ac. which would be 81 minus 4 times 1 times 81, which is less than 0, so there are no solutions, because we've just shown that there are no solutions for y. Is this a surprise? No, because that is y equals 9 over x, which looks something like that. And then the other one's a circle, and they obviously just don't meet. Let's do the next one. Well, we immediately know that one of them has to be 0. So let's say that x equals 0, or y equals 0. But then, if x equals 0, y must also be 0, because from here you'd have 0 squared plus y squared equals 0. So that's telling us that y is also equal to 0, and you can make the reverse argument. But it's not an infinite number of solutions, it's only 2 solutions. Because the 2 equations between them force it that way. Let's do one more. This is the last one. So I'm going to write that as x equals 9 over y. But I'm going to write it somewhere else so I've got more room. Which I then sub in, so I get 9 squared over y squared plus y squared equals 18, which means that 81 plus y to the 4 equals 18y squared. So we've got y to the 4 minus 18 y squared plus 81 equals 0. I'm going to try and factorise this. Wonder what's going to happen this time. My gut feeling is that this does have a solution. It looks to me like it should do. So I'm just going to do my b squared minus 4ac straight away. Because it's only asked how many solutions there are, it hasn't actually asked me to tell me what it is. So ab, that's 18 squared, which is large. So that's bigger than, well, let's say that's at least 400, I don't know, something like that. And then minus a number that's less than 400, so that's minus 1 over 320, which is greater than 0, so there are 2 solutions. But we don't know that, because you got a y squared. Okay, but what I can say is, I'm just being very lazy. There might be someone in the comments saying, Duncan got this wrong. But that's got to be a minus and a minus, because the only way that there can be a plus and that can be a minus. And in fact, I know what it is already. It's just 9 and a 9, because I've just spotted it now. So are there 2 solutions? That would be y squared equals 9, so y equals plus or minus 3. So in fact there were 2 solutions. There could have been 4. There could have been 0, because if those had both been pluses, there would have been no real solutions. And although I didn't say it, I did sort of mean real solutions. There we go. I find this is a really nice exercise to go through. It's just a kind of bit of extreme practice with some unusual equations with an unusual question. Hopefully that was helpful for you.